Welcome back, guys. In this lesson, we'll be doing a quick overview of the concept of security relative to your REST API. Now, when we talk about security, even though it is kind of self-explanatory when we talk about what security is, we kind of have to get into some specifics when discussing how we make an API secure. Now, some of these things are actually already taken into consideration and come out of the box with at least .NET Core API. I can't really vouch for other API development frameworks, but I can vouch for .NET API, where they do kind of enforce or strongly encourage certain security considerations from the get-go, from project creation, and then it's up to you if you want to continue with that. Really and truly, they make it so built in that you don't even realize how secure it might be out of the box. So the first and probably most important one would be to use SSL. So SSL is a standard, well, SSL, TLS, there are standards for HTTP communication, and what they do is enforce some amount of encryption across all communications going, let's say, across the pipe, right? So when you were creating the project, I believe there was an option there to enable or disable SSL. And well, I didn't bring it much attention to it, but if you want to see if SSL is enabled, you can always right click, go to properties, right click your project, go to properties, go down to debug, and then you would see here that enable SSL is there by default. So even in debug mode, they're encouraging you to use SSL. And of course, when you go ahead and publish, you're encouraged to use a proper SSL certificate. Otherwise, you also have access to a very powerful user authentication system in the form of Identity Core, which we will be setting up, which allows you to authorize, authenticate, and let's say sanitize requests based on who you think should be accessing your API. Now, you don't always need that for an API. Sometimes your API needs to be publicly accessible by any and everyone. And then there are some times when somebody needs to sign up, verify who they are before they can access information. Based on our API right now, anybody could come and access the list of hotels or a particular hotel at will. There is no restriction to authenticate and authorize a user before we allow them to do that. However, we will be putting things in place that would allow us to kind of control who gets access to what. Other things like what we expose in our URLs. And when we say URLs, I mean like here remember that when we wanted to get a particular hotel, we had to allow the user to pass that ID. That's not sensitive data. However, if it was something like a password or something that, you don't want the world to see, then you definitely don't want to put it in the parameters. So the way you design, you have a defensive way to design your API that such that you are implicitly securing certain things. So with poor design, you could introduce security flaws. So of course, what you allow to be passed over as plain text or as parameters, what you hash or you encrypt along the way, all of those things aid in making your application secure. Now, with all that said, sometimes we think that we need to have a very, very secure thing, and we try to put every form of security into our API. And that's not necessarily true. As I've always said, context determines a lot. So I'll give you an example. One time I had to develop an API wrapper around a third-party service. And the concept was that this third-party service provided some messaging services that my company would have used for various applications. Now, what we didn't want to do was integrate the third-party endpoint into 5-6 different applications, because if the vendor changed their design or something, then we would have 5 or 6 different touch points that we would have to maintain. Instead, I was put in charge of developing an API that would consume the third-party API, and then the internal applications would consume my API, so that if the third party changed their design, we would only have the one point to change because everybody's consuming our already internal API. Now, when when the company mentioned that, of course, security was very high on the list, and I went ahead and implemented all sorts of authentication and tokens, and we'll be looking at tokens also as we go along, but all sorts of security protocols. And really and truly was overkill because the internal API was just that. It was internal. We had IP whitelisting and very strong network protection protocols surrounding what was operating internally on our network. So to have an internal application need to verify who it is in order to access another internal API before it goes out to the third party. All of that was really overkill. So I'm just giving you a scenario of where I personally I would have implemented something that was overkill. After a while, we just ripped out all of the excess stuff, and we had other security protocols to kind of balance it out. So once again, context determines a lot. However, for this section, we will be implementing authentication, meaning our clients will need to register with our application, with our API application, and they would have to log in, passing in the username and password that they would have used to register. And then subsequent to that, we will be issuing them what we call JSON web tokens or bearer tokens, which will have information that will inform us each time they make a request of who they are. So they don't have to keep on logging in before they can do things. They do that one time, get this token, and pass that token along each time for us to verify and accept or deny. So that is what we'll be doing in this section. Enough of my monologue. Next up, we're going to be creating our identity core or integrating identity core into our project. Hey guys, welcome back. So our first line of security will be for authentication, and to implement the authentication features in our API, we're going to be taking advantage of the built-in libraries of .NET Core. So we're going to be making a few modifications to our database context, our startup, and other little things here and there. So let's start off with our database context, where we have to change it from being DB context to now being identity DB context. So this is just another class that allows us to take advantage of the identity services. And when I do control dot, you see here that you have the option to install the package .NET Identity EF or Entity Framework Core. So you just go ahead and find and install the latest version. And then once that is done, we need to make one more modification to our onModel creating, where I need to say base dot onModel creating. All right, so we have to call the same function in the base class, which is our new base class, and we'll just pass along the same builder object that we are using in the current DB context. Now that's step one done. We'll go over to the startup file and then start making our modifications here. Now what we need to do is configure our identity services to know which class is going to be used to infer the tables that will be generated. So before I move on, let me just backtrack a bit and explain what's going to happen. We're telling our application from the get-go that we want to use our identity services. That's what we're about to do. Now, the identity services will be based on a database connection to, well, a connection to a database that has tables to facilitate identity-related things, user storage, role storage, claims, a number of things. So what we need to do now is configure identity services to know which class is going to inform how the user's table should look, and if potentially there is another one for roles, how the roles will look, etc. So already built in is a user called, or a class called identity user. All right, let me just go ahead and include. So you see it's a legitimate class that's already built in that can be used. Now, if we look at the details of identity user, you'd see that it has fields for lockout, and you don't have to come here. But if you want to get to that point, you can just control click and then continue to control click until you get to that part. All right. So we have these default fields that will come up in the database. As you can see, you have ID, username, email, and password. Well, password hash, right? So those are common fields that any user table needs to have. It's dealing with the hashing automatically. It's always going to have all of that built in, no problem. However, there may be times when we need a bit more information from our users than just email, password, and username potentially. So they allow us to extend the identity user class and put in other fields like we may deem necessary. So I've already kind of started that process. In data, I created this class API user. You can go ahead, right click your folder, go to add, create the new class API user. And then in API user, what I've done is to inherit from identity user. So remember, once inheritance happens, we did that with our DTOs earlier. So we're doing it now with identity user. It's going to automatically inherit all of these fields, as well as any other field that I say I need. So in this case, I just need first name, last name. You could want date of birth. You could want country of birth, area code, other things. Whatever it is you want, you can just extend this class and add them. But it will always have these fields by default. So once you have that class created, you can make two changes. Before we go back to startup, I want to add that class as the context for the DB context. So I'm just using my angle brackets and saying DB context, you're relative to API user, because by default, it's going to use identity user. So if you don't have that requirement where you need more fields, then you don't have to take that extra step. However, it would be good to do that extra step, because later on, if you need to extend it, you can do so without much headache or hassle. All right. So that's one more change that we made to our DB context. Now we need to configure the identity services. So I could do that from here, but I'm going to kind of bring you along another journey now, where we don't want to, sometimes we don't want to keep on putting in, and this startup file just starts to swell, and then you have to scroll through mountains of code to find one configuration. So what we're going to do is go over to our project, create a new class. If you want to put it in a folder, that's fine, but I'll just leave it at this level. So I'm going to call it service extensions. And then inside of service extensions, I'm going to have public, static, void, and I'm going to call this one configure identity. So this class is going to be like, it is the service extension. So any bit of configuration that we don't want to burden in this startup file with, we can abstract it to this and just call the methods accordingly. But you'll see that. So I'm going to say this as a parameter, this, and then iService collection, and call it services. All right. Include any missing references. There we go. And then this is now going to say that I need to have this as a static class. There we go. All right. So inside of this method, I'm going to have a variable. I'm going to call it builder. So basically, builder is just going to be like a amalgamation of us building up the same services that we would have added here. So the same way you would have said services dot, and you add this and add that, we can abstract that over to this class, and then we just call it on the other side. So you'll see in due time. So we're going to be adding or .add identity core, and then we're passing in the user class. So once again, we're using the custom user class API user. So API user, right? And then open and close brace. And I just need to include any missing reference. There we go. And then I'm going to have my Lambda token where I can customize certain things about how it handles the user interaction. So I can set like password policies right here. I can say that all passwords must require a digit or have a minimum length, use unique characters. All of those things are right there out of the box. However, I'm more interested in just making sure that my user, so q.user, and require unique email is true. Right, that's the only one I'm really interested in enforcing right now. However, you can experiment and you can add the others that you feel are necessary. So that is the first line, and then I'm going to say builder is equal to new identity. So most services will come with like a special builder class. I don't want all of that, so I'm just going to say identity builder and include the missing reference. There we go. So new identity builder, give me the builder, right? So that's a builder object that we just started. Dot user type, right? So whatever type was specified, that's what was passing in there. And then type of, because I want to use roles. So the same way that there's a built-in identity user, there's a built-in identity role. So role means, are you admin? Are you user? Whatever it is, that's what that the role means, right? And then after specifying that the role should be there, then I'm passing in the ICollectionServices object in the form of services. After all of that, I'm now going to say builder dot, and we need to tell it where it should be storing or which database it needs to interact with for the identity services to happen. So I'm going to say database context, right? So the DB context that we're using as our database, we're passing in the matching object for that. And one more line to add default token provider. So I did say we'll be using tokens, but later on we'll flesh out the token bit. I'm just putting all of that there. So just for context, once again, this builder object is really just saying I'm building up the everything that needs to be built up to add to the services. That's pretty much what we've been doing all this time. So here we said services dot, and then we had all of these lines and options and going down. The same thing with the core policy and so on. So now that we've extracted all of these lines to this method or to this class and this method, I can now in startup say services dot add authentication, because that's the first thing I need to add authentication. Right, there's authentication core also, but I'm using add authentication. I haven't had any problems with that one so far, so I'll just stay with it. And then I'll say services configure identity. All right, nice and simple. So services.configure identity is basically what we just did here. So you can start looking at it this way. Anytime we have to add in something to the startup, if it's not a one-liner like this, maybe we can start looking to extract these things to that file and have the builders just send over the object whenever it is called. Right? It's not the end of the world, but different people like to see different things. So some people, myself included, don't like to see bloated startup files. And at least when you have that much code, you have to be scrolling through, and then you scroll past the configuration 5 times before you realize it was there. Those little things can get annoying when your application grows. So I'm just showing you a way that you can abstract too many lines of code from your configuration section and have it in a very confined space. So now that we've done all of that, and we've done all of that setup, what we want to do is do a migration now where we'll add the tables for the identity service. So what we'll do is say add dash migration. We know this part. I'll say added user or added identity. Let's just put it that way. Added identity. And once we do that, we get our migration file. So now when you look through, you'll see the different table names. We have the ASP.NET roles table. We have ASP.NET users table. And if you look very closely, you'll see that in addition to all the default fields that we saw earlier, we also have the custom ones that were added to the class. All right, first name, last name. So when it's going to scaffold this table, it's going to put in our custom fields. All right, just the same way we could have overridden the roles, and if we wanted more information on roles than this, we could have added a custom class, extended it, and it would have done the same. So let us go ahead and update our database. And with all of that done, we have finished our configuration for our identity services. So you can give yourself a pat on the back. However, most of what we've done is in the background. If you want tangible evidence of something being done, you can always check your database and you'll see the tables that have been generated accordingly, right? But our next step is to actually set up the endpoints such that the users can pass over information and get registered as users of our API, and also for them to log in. And then after that, we'll talk about how we continue to verify that this user should have access after they have logged in.